Hello everyone, this is us again, Rapid Prototyping Lab, ERAU Prescott. Today I am with Mr. Matthew Clark, our lab manager and the most knowledgeable technician. He is going today to talk about the Resin Printer Formlabs Form 2. So without further ado, I'll pass it all to Matt. So the class is yours.
All right, so as you mentioned, this is our laser resin printer. This is the only laser resin printer that we have within the lab. You can see it's actually 3 different systems. You have the printer itself, you have the wash station for the printer, and then you also have the cure station for the printer. As it is a laser resin system, you need all 3 of those stations. The resin itself starts out as a liquid, which is hardened by the laser within the printer itself. It's got a whole mirror system within it. It's sort of interesting. It builds at the bottom and then slowly raises the platform to the top. You can see it has a shield on the top of it. Try and keep out any sort of outside contaminants and then also shield it from the light. That's why it's got that orange color to it.
So the parts will be printed upside down, right?
Correct. The parts are printed upside down. It also has a removable tray so you can swap out the different types of resins that you're using. And then if you were to look at the bottom of the tray, it's actually transparent, which allows the laser to go from the bottom to the top, harden each individual layer, and then move it up a little bit to go on to the next layer. What's so neat about this system, though, is that it's a lot easier to control light than it is to control the whole gantry, as opposed to what a typical Cartesian printer would do, which allows you to get a lot better precision as far as printing goes. And the layer height on these is as low as 0.01 micron, or sorry, 25 microns, so quite a bit more precise than your traditional style Cartesian printer. Then, as we mentioned, there's 3 different stations. It features a removable build tray, which can then be moved directly into the wash station. Because as the printer is printing, it goes up and down into that bath of resin. So you have the hardened bit of resin in the middle, but it gets coated with the liquid resin on the outside. So you have to remove that once the print is done. So all you do is put that into the wash station, and this is filled with isopropyl alcohol. It's just got a little system that lowers the print into the bath and then just spins it all around to clean off any sort of excess resin that is within the print.
What is the percentage of the alcohol, the isopropyl?
So the alcohol has to be at least 91%. It has to be fairly pure to actually get the resin off. Resin is a little bit weird. It's not really soluble in water. You need to have that alcohol to actually remove it and make the system clean.
And could you tell us before you move to the next, is there any hazard in any of these resin? Are they going to, when touched by the skin, are they gonna irritate the skin or anything? So because they are not as safe as let's say PLA or so, right? So any special care when working with these machines, that special covering, PPE, anything like that?
Correct. All of the resins are considered hazardous, so you need to be wearing gloves when utilizing any of these materials and make sure that it's not going to splash onto you. So that's always a precaution you want to take, and then dispose of the resin through the proper facilities.
Do they have to have goggles on too?
Yes, you're supposed to have goggles on.
So goggles, coveralls if you have, and definitely you want to have gloves if you can have some covers on your shoes too, because the resin is, as Mr. Clark clearly mentioned, is a hazardous material, and anybody who is working with this printer also has to be trained about the potential hazards of resin. Okay, please go ahead.
All right, so after we remove the print from the wash station, it then needs to be removed from the supports that are within it. All resin prints need to be printed with supports. It's actually a little bit different with the resin printing. It bonds to the actual metal surface itself stronger than it bonds to its own material. So if you don't put a support on the build tray and then to the part, you'll end up ripping your part in half, half of it being on the build tray and then the rest of it being the part that you're trying to manufacture.
What is the approximate time that it has to be in the wash machine before you take it out?
Approximately 15 to 20 minutes. It really depends on the geometry. If you have really small holes, that's something you have to consider. But other than that, as long as it's an open geometry with no concave surfaces, it tends to be fairly easy to clean.
Understand. Thank you.
All right, and then once we removed the part from the wash station, cleaned it all off, and removed the supports on the excess that we can, it goes to the cure station. And all this is a UV light and a turntable. It's important to have the turntable on there because you want to have a equal distribution of light on your part while you're curing it. And then also each individual resin has to be cured at a specific temperature. So you can see here we have a time and a temperature for each resin to be cured at. We'll just set that at 35 and start. And you can see when we start it, the printer or the cure station starts to rotate the turntable and then heat up. For example, the rigid resin is about a 2-hour cure time at 80 degrees C, whereas if you were to go to a tough resin, which is a little bit less industrial in strength, it's going to be a lesser cure time and a lesser temp as far as the curing goes. That about sums it up.
Okay, and now for those who want to, let's say, buy a printer like this, should they necessarily buy the wash machine and the cure machine, or if they are on a budget, is there any cheap or free alternative to the cure and wash, like, for example, pouring alcohol in a container, putting it in front of the sun or something like that?
There's a lot of different lower-end printers that utilize the laser resin system, and they don't really need a cure and a wash station. It's more so due to the size of this print and trying to get consistency out of the prints that we have the wash and the cure station. When you're really looking to lock down the material strength properties, it's important to have the cure station where you can control both the temperature and the UV light distribution, but if you're not really worried about structural properties as much, it's fine just leaving parts in the sun.
So sun, UV light can cure as well. Of course, it's not going to be as controlled and uniform as having it in a closed container, right, with the turntable. And you can also have like a bucket or something filled with the same alcohol and just dip the part in it and let it there, right? And could you give us like a rough estimate of the price of each component? So if you want to not buy those 2 other pieces, how much would that save you in terms of money?
I don't remember the exact cost of the foam wash and cure station. I think it was between $500 and $1,000, but the printer itself was $3,500, so it's a fair portion of the price.
Absolutely. As far as I remember, I guess it was like both of them together was like $1,500 or somewhere between $1,000, as you correctly mentioned, to $1,500, and the printer is like $3,500. So the whole bundle is about $5,000. And if you not buy those 2, the printer itself, then you end up $3,500 or a little bit above for, you know, annual protection, maintenance contract, and so on. There we go. So now, is it just a starter?
Yep. So now it's finally reached the goal temperature, and once it reaches that temperature is when it starts turning on the UV light, and they'll be turning it on the turntable throughout that entire heating process, just to try and more evenly distribute the heat.
And so the temperature and the time in the cure machine is also depending on the type of the resin, right?
Correct.
That's okay. Perfect. Okay. So could you tell us the rough print size of this form too? Like what by what you can print this one?
So it's roughly 14 centimeters by 14 centimeters by 17 centimeters.
In height, right? 17 is the height.
Correct. 14
Okay.
by 14 for the base length, and then the 17 for the height. So relatively small, but you can also angle your parts at whatever angle you want because it has that different support system, so you can fit a fair volume within that constraining factor.
Okay, and how nicer, how smoother, how much smaller detail this guy can print compared to a FDM printer?
Since you can get the layer height down to 25 microns, that's roughly like a quarter of the layer height of the best you're ever going to see on an FDM machine. So it's substantially finer than you can ever do on an FDM machine. You basically can't see the layers at that height, and it just feels smooth to the touch. with the exception of the fact that you have to have the supports on there, which need to be removed and then sanded off if you're going for a very fine.
But that makes the print time a little bit longer, right? Compared to, because your layers are really, really small. 25 microns is a very small thing. Here is a sample print. Let me bring it as close as possible. So this is like the rook in chess. And although this whole thing is about 1/3 of one of my fingers, as you can see, or smaller, but there are stairs in it. I'm not sure if you can see. I'll try to add a picture for it. There are stairs in it, and it captured all of those too. So you can print parts that are smaller than your thumbnail or any other nail, and you can get all of the details of that. And this is something that is almost impossible for even the best FDM printers to capture. And could you tell us a little bit about the cost of the resin? Because some people might say, well, if that can give me such amazing print, then I gotta print every print of mine with resin instead of FDM. So what about cost-wise?
So cost, they sell it by the liter as it is a resin in a liquid system. Depending on which material you're using, it ranges from basically $150 to $250 per liter. If you're comparing that to an FDM machine, such as PLA, the liter volumetrically is a little bit less than you're going to get with a kilogram of filament, which roughly costs $20 per spool. So you're looking at about 10 times the cost of material. So there's definitely a price associated with the precision.
Order of magnitude, right? More expensive. And this is a quite reliable printer, right? This is one of the good resin printers. And we are going to get a bigger version of this called Formlabs 3 Large, 3L. And that one should definitely increase the print size that we have over here. Is there anything else about the hardware aspect of it that you want to share with us?
I think that pretty much covers it.
Covers it? Okay. So if that is the case, now we are going to switch to the software, the slicer software of Formlabs. And Mr. Clark is going to show us the details about that.
Alrighty, so next we're going to go over the slicing software for the Form 2 printer. So you can see when you open up the program initially, it allows you to select the printer and select the resin that you're using. For the purposes of this demonstration, we're going to be using the Rigid 10K. That is the resin that we use the most in the lab, as it tends to be more rigid than the other ones, which for aerospace applications, when you're looking at a specific geometry that you're trying to replicate for a wind tunnel or whatnot, is the most practical resin to use. So we will scroll down to that. Then we can adjust our layer height anywhere from 100 to 50 microns. Next, we're just going to open up a print. So for this, we're just going to use a piece of a pitot tube that was submitted. Alright, so here you can see the stem of the pitot tube. As we were mentioning earlier, with the form printer and laser resin printers in general, you don't want to do a flat surface to the build tray because the adhesion to the build tray is stronger than to the part itself. So if you were to try to remove that, you would probably just snap the part in half. So we're going to want to orient it in a little bit of a weird way compared to other printing styles. You always want to make sure with the laser resin printers that you're starting from a point and then building off of that point. The more gradual you can build from that point, the better. And you'll see that in a minute here when we get the supports going. We like to select mini rafts here at the lab. The difference is the plate that it's building at the bottom where the supports come off of. The full raft is going to make a whole cross section at the bottom, whereas the mini raft just builds the supports alone, which saves on the resin. And then the rest of these different settings, density is the ratio of supports that it's putting on your part, and touch point size is the actual diameter of the touch point that is attaching to your part. Generally, you just want to stick with the standard defaults on the software itself, as it is a very finicky item to change. However, if you're fairly experienced with the software and the resin that you're using, you can usually reduce those a little bit. Alright, so now we're just going to wait for the software to generate the supports. Alright, so here you can see the whole support structure that the software has made for our part. Obviously, it's a lot different than an FDM machine, so you're only starting from individual points. On the right here, we have a scroll bar, which is going to show you the progress of the print layer by layer. So as I was mentioning earlier, we're starting from an individual point on the part and then building up from there. So that's the initial cross section, and then slowly it's building up part as we're going through. So something you might want to consider when using this type of printer is that removing the supports is fairly difficult because it's made out of the same material as your model material. So you're going to have to break all those off manually, either with clippers or just by twisting it. And then if you're trying to get a smooth surface, you're going to want to sand those down once it's post-processed. So if you're looking at a precision item, you might not want to have supports within the structure. So for example, this pitot tube, you wouldn't want to have supports on the inside of the tube itself because it's going to be fairly difficult to remove. However, thankfully the software makes that fairly easy to edit, and we can unclick internal supports and reslice the software for the part so that those are removed entirely. Generally that works out. Sometimes it doesn't, and it says that the model isn't adequately supported. If that's the case, you just have to adjust the orientation and then try again. Alright, we can see that time it did not work, so we're going to have to manually remove the supports within the structure. So another option is to manually do the supports on the object. You can see here, this is where all the different touch points are. If we just click on those, we can remove them throughout the structure. And then reslice the object. You can see that there's this red area that's starting to build as we remove those. That means that the part is less supported in that area, and it's under stress, which is going to reduce the model accuracy when it's printing. However, when we remove those, we can see on the right here that it still says the model is printable. That's not always accurate. Sometimes you'll print it and it fails, but generally speaking, that's a pretty good indicator of whether or not the print will work. And now we don't have any supports on the inside of the part, so it should print fairly easily and accurately. And when we get to the post-processing stage, the end product won't have to have any sort of modification to the inside of the tube, which should definitely be beneficial. Another thing to note is print time. Always make sure you refresh that setting, so we'll see just about how long this would take. Keep in mind that this is a 14 by 14 by 17 millimeter rectangular prism that this part's fitting in, so it's relatively small, and even though it's that small, it's still going to take 12 hours and 20 minutes to print, which is a fairly long time, especially if you were to compare this to a FDM machine, which would probably be in the realm of 3 to 4 hours. That's the basics as far as the slicing software goes for the Form 2 printer. That's about it, really.
Okay, thank you so much, Mr. Clark. I absolutely appreciate your time, and we will see you in the next video. Thank you so much.